Hi everyone! Today I'm going to present Stylized Surface, a master material designed for both stylized and realistic workflows inside Unreal Engine 5. This shader allows you to blend multiple textures using Vertex Painting while supporting both traditional UVs and Triplanar Mapping. The goal is to create infinite surface variation while reducing visible tiling and texture repetition. The shader also supports Nanite Displacement and Tessellation style surface depth, allowing you to achieve a much more premium and detailed result directly inside Unreal Engine. In this tutorial, I'll show you how the system works, how to paint textures, how to customize the material instances, and how to create layered stylized surfaces like plaster over bricks, painted walls, moss, or edge stone. Before we begin, there's one important step. If you want to use Nanite Displacement, you need to modify your DefaultEngine.ini file. Inside your project folder, go to Config, DefaultEngine.ini, open the file with Notepad. I'll include the required lines directly in the video description so you can simply copy and paste them. Once this is done, Nanite Displacement should work correctly on your meshes. As you can see here, the surface depth becomes much more visible once displacement is enabled. Now, there's an important limitation you need to understand. When using Nanite Displacement together with modeling mode Vertex Painting, Unreal modifies the actual mesh itself. For example, if I paint directly on this mesh and accept the changes, the mesh is permanently modified. That means if multiple instances are using the same mesh, they will all inherit the same painted result. So, if you want different painted variations while using Nanite Displacement, you'll need to duplicate the mesh. I know this isn't ideal for optimization, but currently this is one of the limitations of using Nanite with modeling mode painting. Hopefully Epic improves this workflow in future versions of Unreal Engine. Now, if you don't need Nanite, you can disable it directly on the mesh. Right-click the mesh, go to Nanite, then select Disable Nanite. Once it's disabled, you can use regular mesh paint mode instead. The advantage is that you can paint different variations directly on mesh instances without modifying the original mesh. This workflow is much more flexible for creating variation across large environments. As you can see, each instance can have its own unique vertex painting, which helps create a lot more visual variety across the environment. Now let's create our material instance. Inside the materials folder, go to the master material. Right-click, create material instance. Personally, I like to name my instances using the prefix MI. For this tutorial, I'll name it MI Stylized Surface Tutorial. I'll open the material instance and dock it on the right side of the screen so we can see both the viewport and the material controls at the same time. I usually use the Windows key together with the arrow keys on the keyboard to quickly snap the windows left and right. Then I'll simply drag and drop the material instance onto the mesh. Now we're ready to begin. The first section contains the global parameters. By default, Vertex Paint is enabled. Most checkboxes are disabled initially. For example, displacement is disabled, emissive is disabled, stylized mask is disabled, wetness is disabled. This allows you to activate only the features you actually need. Let's talk about the stylized mask. This feature adds an additional painterly layer on top of the surface. It creates subtle brush stroke variation that helps give the material a more hand-painted look. You can adjust the texture itself, the tiling, the color, the contrast, and the intensity. This creates subtle painterly variation across the surface. You can keep it very soft and natural or push it further depending on your art direction. The material is built around 3 texture layers. Layer 1 is usually the base surface. Layer 2 is often the first blend layer. Layer 3 is the secondary blend layer. For example, bricks, stucco, moss, painted plaster, or damaged stone. Each layer contains base color, normal map, and ORD textures. ORD stands for occlusion, roughness, and displacement. Now let's assign our textures. For layer 2 and layer 3, I'll add 2 different stucco textures so we can paint variation between them. Inside each layer, enable base color, enable normal map, enable ORD. You can use the small folder icon or press Ctrl+B to locate the textures inside the content browser. All textures included in this package were created by me using ZBrush and Substance Painter. For example, the bricks were sculpted in ZBrush, the stucco surfaces were authored manually, and all supporting texture maps were generated specifically for this shader workflow. If modeling mode does not appear in your project, you need to enable the plugin. Go to Edit Plugins, search for Modeling Tools. Then enable the plugin and restart Unreal Engine if necessary. Now, let's start painting. Go to Modeling Mode. Attributes, Paint Vertex Colors. By default, I usually set the paint color to black. If Vertex Paint is disabled inside the material instance, painting will not work. So make sure Vertex Paint is enabled first. You also need to make sure layer 2 and layer 3 textures are assigned correctly. The material uses RGB channels for texture blending. So the red channel controls the transition between layer 1 and layer 2. The green channel controls the second blend layer, and the blue channel is used for wetness. If I paint using the red channel, the first stucco layer appears over the bricks. If I switch to green, I can paint a second variation. This allows us to create much more organic and believable surfaces. You can paint, erase, fill, or blend manually. The flow value, you can create softer transitions and more natural results. Now let's enable displacement. When enabling displacement, make sure your mesh uses Nanite. Otherwise, displacement will not appear. At first, the effect may look subtle, but once we increase the displacement amount, we begin to see the surface depth much more clearly. This creates a real physical depth on the mesh rather than relying only on normal maps. In this case, we are not going to use emissive, so let's move to the Stylized Mask section. The Stylized Mask is an additional grayscale texture that helps add more artistic variation to the surface. We can change its color, contrast, and tiling. If I increase the stylized mask intensity, you'll start seeing those hand-painted brush stroke details appearing on the mesh. For demonstration purposes, let's use a more saturated color so the effect becomes easier to see. We can also adjust the contrast and the tiling of the stylized texture. Right here, you can also replace the grayscale texture itself. Of course, you can use your own textures depending on the art direction you want to achieve. Now let's move to wetness. This option allows us to create puddles and wet surface effects, like the ones you can see on the ground. Select your mesh and go back to modeling mode. Now let's start painting some wetness. By increasing the wet roughness values, we can make the surface more reflective. We can also flatten the normals to create a smoother puddle effect and adjust the darkness value to make the wet areas darker. Now, let's reset the values back to their default state. Now let's talk about triplanar mapping. This is extremely useful when meshes have poor UVs or no proper UVs at all. By default, triplanar is disabled. If I enable it, you can see the UV's problems fixed on this mesh. So I'll enable triplanar again. The default scale is set to 400 centimeters, which works well for a standard 4-meter wall. Of course, you can customize this depending on your environment scale. Each layer also supports color variation. This feature allows you to subtly break texture repetition. For example, I can add warm tones, cooler tones, painterly color shifts, or aged variation. Even very subtle color changes help environments feel less procedural and more natural. You can also control intensity, saturation, contrast, and tiling. The color override parameter lets you completely tint a texture. For example, white plaster can become blue paint, sandstone can become red clay, or you can create entirely different art directions without reopening Photoshop or Substance Painter. This is extremely useful for fast iteration. Now, by lowering the base color contrasts, we can gradually remove most of the original color information from the texture. As you can see, the stones become much more neutral and desaturated. This is very useful because it allows us to completely redefine the final color directly inside the material instance. Instead of being locked to the original texture colors, we can direct the surface much more freely. For example, we can turn these stones into warmer tones, colder tones, painted surfaces, or completely stylized color palettes without needing to modify the texture itself in Photoshop or Substance Painter. This gives us a much more flexible workflow for creating different environment variations very quickly. Each layer also contains normal map controls. You can replace the normal map, increase normal intensity, or reduce it for flatter surfaces. For stylized environments, I usually prefer slightly softer normals, but for bricks or stone walls, stronger normals can help surfaces feel more detailed. Now let's look at the ORD texture. The ORD texture packs 3 grayscale textures into a single texture map. Red channel equals ambient occlusion, green channel equals roughness, blue channel equals height/displacement. This packed workflow is much more memory efficient. The blue channel is also used for height lerp blending. This is what allows the stucco to naturally fill the crevices between the bricks. At the same time, this height data is also used for displacement. You can't control roughness intensity directly inside the material instance. If you want wetter surfaces, shinier stone, or very matte plaster, you can easily adjust the roughness values. Ambient occlusion intensity can also be increased for deeper cavity shading. This helps accentuate the sculpted detail. Now let's look at the displacement controls. You can adjust displacement amount, smoothness, contrast, and height intensity. The displacement result depends heavily on the black and white contrast inside the height map. Darker areas push inward, brighter areas push outward. This is very important to understand when authoring textures. Now let's create a layered plaster effect. I'll fill the mesh using the stucco layer. By adjusting the smoothness, displacement contrast, and amount values, we can control how the stucco reacts around the bricks. As you can see, the plaster starts following the shape and contours of the underlying stones much more naturally. This helps create a more realistic layered effect, where the stucco feels like it is sitting on top of the surface instead of looking like a simple flat blend. By increasing the contrast, we can make the transition sharper and reveal more of the brick shapes underneath. The smoothness parameter helps soften or tighten the blending between the surfaces. And finally, the amount value controls how strongly the displacement affects the material. Don't hesitate to experiment with these values to achieve the exact look you want for your environment. By lowering the paint flow, we get softer and more natural transitions. This creates the impression that the plaster is worn away over time. Let's add some color variation. The color variation parameters help break the uniform look of the surface and make the bricks feel much more natural and believable. Even subtle color variation can add a lot more visual richness and help avoid the repetitive look that often happens with tiled textures. This is especially useful for stylized environments, where adding slight hue variation can make surfaces feel more handcrafted and organic. Now, let's start painting the third layer. This layer uses a smoother and less rough stucco surface, which helps break the repetition and adds more visual variation to the material. Don't hesitate to experiment with the displacement, smoothness, contrast, and amount values to achieve the look that works best for your surface. Once we accept the painting changes, the displacement becomes visible again, and now the bricks physically push through the plaster. This gives a much more convincing result than flat blending alone. One interesting trick is adjusting displacement values independently per layer. For example, bricks can sit deeper, while painted plaster slightly protrudes outward. This creates the illusion that paint or stucco sits physically above the surface. Small adjustments here can dramatically improve the final look. One of the strengths of this workflow is that the same master material can generate many different surface styles. For example, blue walls, white plaster, orange painted surfaces, aged stone, damaged stucco, brick walls. Most of these variations are simply different material instances using slight color changes, different texture combinations, and unique painting passes. This allows you to create large environments very efficiently. One final reminder, if you use modeling mode painting together with Nanite Displacement, Unreal modifies the source mesh itself. So always duplicate your mesh if you want unique painted variations. Otherwise, the changes may affect every mesh using the same source asset. If you prefer per instance variation instead, disable Nanite and use regular mesh paint mode. And that's it for this tutorial. Well, as you can see, this shader allows you to create highly customizable, stylized, or semi-realistic surfaces directly inside Unreal Engine 5. Using Vertex Painting, Triplanar Mapping, Nanite Displacement, and layered material blending, you can quickly generate rich environment variation while keeping a very flexible workflow. Feel free to experiment with K-Toast displacement, color variation, stylized masks, roughness, and texture blending. If you have any questions, feel free to leave them in the comments. And if you enjoyed this tutorial, don't forget to like the video and subscribe. Thanks for watching. See you in the next video.